The graph you see here is a graph of what is called the Lorenz curve. This is an important way to measure income inequality, and the way we sketch the Lorenz curve is we rank individuals from the poorest to the richest. So we're saying if there are 100 people in the population, you'd rank from the poorest person up to the richest person. Then you'd ask the question, what percentage of the income does the poorest person have? And what percentage of the income do the 2 poorest people have? What percentage of the income do the 3 poorest people have? You keep asking that question until you get to the point where you ask what percentage of the entire income is held by the poorest 50%. And obviously 100% of the population would have 100% of the income. And the Gini coefficient is the efficient way to measure income inequality as a number. So you would ask the question after you've sketched the curve, what percentage of the area of this square is area A, the area between this line and the curve, divided by the bottom half of this rectangle or square. A plus B is the denominator, and A gets to be larger, the worse is the income distribution, and A gets to be smaller, the better is the income distribution. A simple example of the Lorenz curve and the Gini coefficient. In this example, I'm going to divide the population into 2 groups, the rich half and the poor half. So here in table 1, I have the bottom 50% of the population, and I say the bottom 50% earns 30% of the income. That leaves the top 50% with 70% of the income. When we accumulate, we would say that the bottom 50% has 30% of the income. The entire population has 100% of the income. So you see the difference between the 30 and the 100 is the 70% of the income going to the top group. Table 2 makes the assumption that each group has half of the income, and when we trace out the line that passes through what each group has, when you accumulate it, you would have the bottom 50% with 50% of the income, and the bottom 100% or all with 100% of the income. This will always be the case when you accumulate. So if I were to trace out the 50% having 50% of the income, that would be a diagonal line. This line right here would be 50% of the population having 50% of the income. Actually, it would be 1% of the population with 1%, 2% with 2%, 3%, 20% with 20%, etc. That's called the line of perfect income equality. And the actual data for the country, based on ranking the poorest to the richest, and then accumulated across the population, traces out this thing called the Lorenz curve. Obviously, if I only have 2 groups, then the Lorenz curve is 2 straight line segments, because I'll only be plotting 1 point. I'll be plotting at 50% of the population, so the midpoint on the horizontal axis, and I'll be plotting 30% of the income, so 3/10 of the way up on the vertical axis, which is the income axis. So for instance, I'd say 50% of the population is right about here, and I would ask the question, what percentage of the income does that group have? So if I say here's 50% of the population, and that 50% had 30% of the income, my point would be right about here. And then I would trace out the line segments, and it would look something like this if the point is right here, starting at the origin. So that would be approximately the first line segment, and the next line segment would go up to the top corner, and therefore we trace out our Lorenz curve. For the data I have, area A would be the area between the 2 line segments and the line of perfect income equality. That would be a lower degree of income inequality. Again, the smaller is area A, the less is the income inequality. In order to calculate area A, I say you can divide it into 2 triangles because I have straight line segments. And if you were to do that, you could calculate the area of each of these 2 triangles. Suffice it to say that area A plus B is going to be half of my square. So the axes go to 100, 100% of the population, 100% of the income. Area A plus B, which is 1/2 of this overall square or rectangle, depending on how you sketch it. The area there would be 5,000, so my denominator is always going to be 5,000. In the numerator, if I had 50% of the population with 30% of the income, my numerator would be 1,000. I want you to do this calculation for yourself. so that the Gini coefficient would be calculated as area A over A plus B, which is 1,000 over 5,000, which is 0.2. I make the note that if the Gini coefficient tends towards 0, then the income inequality is lower. The Gini coefficient tends to 0 as the Lorenz curve approaches the line of perfect income equality. Here's another numerical example. Suppose I have 10 people in the population, and the bottom 5, each individual in that group earns $6, and each individual in the top group earns $14. The entire GDP or income in the country would be 5 times 6, which is $30 for the lower half, plus 5 times 14, which is $70 for the upper half. So this is 30% of the income going to the bottom 50%, and 70% of the income going to the top 50%. In my example, I said, let one of the 5 poor individuals rise into the top half and earn $14. Because instead of earning $6, she would earn $14, then her income is going to increase by $8. So the GDP will increase by $8 to $108. And now we can calculate the bottom 40%, or those 4 who are left in the bottom group. And they are going to earn 4 times 6 is $24. And the top group is going to earn the rest of the income. So I have $24 over the total of 108. So the bottom 40% earns 22% of the income. And I show those data here in table number 4. And if you were to plot the curve, you should be able to plot 40 on the horizontal axis and 22 on the vertical axis. Locate that one point and then trace the 2 line segments that pass through that point from the bottom 0, 0 coordinate to the top 100, 100 coordinate. And then the area A will be defined by those 2 straight lines. We can calculate area A. It's going to be 889. A plus B is still going to be 5,000. So you can calculate the Gini coefficient as 889 divided by 5,000, which is around 1777 or 0.1777. And 0.177 is lower than 0.2. 0.2 being the Gini coefficient when we had 5 individuals earning $6, or 50% of the population earning 30% of the income. This is a very simple calculation, so be very careful when you do the calculation. So let me summarize what we have here. We have the Lorenz curve, and in our analysis we'd have a Lorenz curve that moved closer to the line of perfect income equality, and that would say that things are getting better in the society.